So this lesson, reasoning with linear equations, is kind of an interesting one, and I think the best approach is going to be for us to go through all four of these examples. Now, the thing we need to pay attention to, I think the biggest thing as I was going through this, is that what you do to one side, you must do to the other. I'll write that down. What you do to one side, you must do to the other. And that's the main thing. Now, the thing is, you can still distribute. Just because you distribute on one side, that's not changing anything on that side. If you're going to change a value on one side, you better do the same change to the other side. So if you add 3 to one side, add 3 to the other. Distributing is different. Distributing is fine. And you'll see what I mean right now. So let's take a look at this one. So 2x minus 1 plus 3x equals 0. So to go from this step down to here, what did they do? It looks like they combine like terms. So combining like terms is not changing anything on that side as far as the values are concerned. So it's not like if you combine the 2x and the 3x, you need to do something to the other side as well. You didn't add anything to the side. You didn't take anything away from the side. You just kind of simplified that side. That's it. So that's not going to change the quantity or anything. So how do we get from equation B, or how do we get equation B from equation A? We did it by combining like terms. So did we add or subtract the same quantity to both sides? No. Did we add and subtract quantity from only one side? No. Did we rewrite one side by combining like terms, or both? Yes. We didn't use the distributive property. And the reason why I was making such a big deal is I forgot on this one, but number 2, they're going to ask you, based on the previous answer, are they equivalent? So for that, for the number 2, yes, they are. It's okay. You can combine like terms on one side and not the other. You can distribute on one side and not the other. That's fine. It's when you start adding or multiplying or subtracting or dividing to one side, when you start changing the quantities, that's when you got to worry. All right, let's look at this one. So here, we distribute the 3. Or wait, never mind. That's not what we did. I'm jumping steps here. I'm so sorry, guys. So how do we go from here to here? Actually, it looks like they divide the 3. And did they do it to the other side? Yes, because this is a 6. So that's good. If you divide it on one side, make sure you divide on the other side as well. So we multiply to divide by the same non-zero constant? Yes. And it's both sides, right? So that's kind of the important part. Let me highlight. It looks a little cleaner. So we divided both sides, not one side. So it's going to be C. And since we did it to both sides, then yes, they are equivalent. All right, let's look at this one. So 5x plus x, and then we have x minus 4. So this side stayed the same, but somehow this side changed. So how would we have changed that side? It looks like we got rid of that negative 2. So I'm not sure how we would do that. Well, we could add 2, but if we do it to one side, don't we have to do it to the other? Yes, we do. And it doesn't seem like that happened because this didn't change. So we added the quantity. We added, so that's good, to only one side. Yeah, only one side we did it on, and that's not good. So no, we are not going to get the same answer. It's not going to be the same equation. And last, this one here, it looks like we divided both sides by x. Look at how the x is gone. The only way I can think of that is if we divide by x and divide by x. X's cancel out, right? Leaving us with 5 equals 3. So we divided both sides. Yep, divided both sides by the same constant? No, by the same variable. And based on the previous answer, are the equations equivalent? In other words, do they have the same solution? So this equation is not equivalent. Now, this is kind of a tricky answer, and I'm kind of curious because this wasn't equivalent to begin with. So I'm going to say yes, these are technically the same, but this equation is not even equivalent. This equation would have no solution, which we're going to go over in the next section.